What do cherry tomatoes, sesame seed oil, and green tea have in common? Well, if you've never seen a demonstration for a water ionizer, you probably have no idea. But one of the selling points for water ionizers are the other special waters they claim to make. It is because of these waters that proponents claim that you can get rid of a lot of your cleaning and hygiene products and replace them with these, making the large price tag of a water ionizer seem worth it because you won't be spending so much money on so many other things. But is that all the way true? Today we're going to go over some misconceptions and facts about the special waters from a water ionizer. So before I get into the topic, let me first thank our peeps who support us at Patreon. These guys on the screen are part of our advanced community. Companies that support the education that we are doing because it's so important that people know the truth about hydrogen. When people know the objective facts or the truth about hydrogen, it helps the industry as a whole. And unfortunately, many people aren't really telling the truth. And worse yet, some don't even know the truth and continue to spread misinformation or misconception. Speaking of that, this is a misconception video. A video where I get to tell you the truth about a topic that people have been talking incorrectly about for years. Today we're talking about the special waters from water ionizers. I'm going to talk about 3 specifically: strong alkaline water, mild acidic water, and strong acidic water. So let's go ahead and get into the first one. Strong alkaline water, or sometimes referred to as 11.5 water. This is water that is produced on the highest alkaline setting from an ionizer. More often than not, salt is added as an electrolysis enhancer to produce this type of water. This results in water that has a pH of 11 to about 13.8 pH and contains sodium hydroxide and dissolved hydrogen gas. Now, another name for sodium hydroxide is lye. So you can say this is a very diluted lye solution with varying levels of dissolved hydrogen gas. There are many claims about this water, which includes emulsifying oils, fats, or lipids, acting as a cleaner or degreaser, removing pesticides from produce, reducing fats and cholesterol in the body, and some even consume it believing it will have even greater health effects. All of this, of course, is claimed to be chemical free because the water comes from an ionizer, which I find funny because the idea of chemical free in popular culture is such a misnomer. Because by definition, a chemical is a molecule or substance that has a defined composition. Hence, by definition, water is a chemical. But I digress. So let's go through these. A popular demonstration with strong alkaline water is mixing it with sesame seed oil and watching the oil and water turn into a milky substance. What is happening there is the sodium hydroxide in the water reacts or hydrolyzes triglycerides in the oil, forming carboxylate compounds. Carboxylate compounds or salts are the primary agents in soap. Therefore, the initial process seen in this demonstration is not emulsification, but actually something called saponification, which is a common step in the process of making soap. Once carboxylates or soap is produced in the water, they form micelles, which in turn emulsifies the oil. This is why the water appears to mix with oil. Some have claimed this effect is due to the water being microclustered, which is a false claim. We address that fixed microclusters in water is not supported by any scientific evidence here. Thus, this water will break down fats, but not for the reasons the majority of people claim. And I suppose you can use it as a cleaner or degreaser, but it's definitely not chemical free as is often referred to. Now, the next claim to address concerning this water is that it can remove oil-based pesticides from your fruits and vegetables. As stated before, this water can break down fats, which is a good thing. So it follows that the water should be able to remove oil-based pesticides found on your produce. The issue with this claim comes down to the demonstration used to show this effect. The number one demonstration to show this effect is pouring strong alkaline water over cherry tomatoes and then watch the water turn instantly yellow. First, the tomatoes produce a yellow water because their skins contain a natural pigment compound called anthocyanins. These compounds become more soluble in a higher pH water, changing the color of the water. These compounds basically act as natural pH indicators. So the yellow color of the water is not the oil-based pesticide. Majority of oil-based pesticides used for produce are white oil. White oil is colorless for obvious reasons. Who wants the red tomatoes looking pink? This effect has actually been demonstrated with pesticide-free produce as well. Tests have been conducted with this water showing that it can remove oil-based pesticides, but only after soaking the produce for 10 to 30 minutes. It is not instantaneous. This also explains the demonstration where this water appears to make tea on its own without heating up the water. Tea contains catechins, which are natural phenolic antioxidant compounds. These catechins are acidic and readily react with alkaline water, making them more soluble. Therefore, the tea comes out of the bag faster. This effect has everything to do with pH and not microclustering of the water or any other reason. Another claim for this water is that it can reduce cholesterol in your body because it can break down fats. This one is pretty absurd. As stated already, it's the higher pH and sodium hydroxide that is solely responsible for breaking down the fats. The pH of the water will be immediately altered or lowered by the stomach and further buffered or altered by the blood. If this water was able to break down fats in the blood as seen in the demonstration, it would immediately kill you. Yikes. Finally, there are a few other misconceptions concerning this water, but we will not cover them in much depth. We plan on doing a part 2 of this video, which will be an experiment video, where we'll walk through all of these demonstrations and more, showing you the effect and the facts about what you're actually seeing. Now back to those other few claims. It is claimed by many that this strong alkaline water has reduced surface tension. The funny thing is, it's actually the counter opposite. This water actually has increased surface tension because of the pH and the added salt. A demonstration for this claim is to put some of the water between your fingers and feel how silky or slippery it is. This effect is not due to the reduced surface tension of the water, but to what we have already explained. The water breaks down fats in your skin, causing it to feel silky or slippery. It will also do this in your mouth, your throat, or your eyes if you want to use them for eye drops. But I would highly discourage anyone from doing that. The second special water we will be covering is mildly acidic water. Mild acidic water has also been referred to as beauty water. This water is produced from the positive electrode or anode of an alkaline water ionizer. The water generally has a pH of 4 to 6 pH. The water is claimed to be good for your skin and can be used as an astringent or toner. Now, the pH of the skin ranges from 4 to 6 pH, so technically this water will not disrupt the pH of the skin very much. To label it as an astringent might be a stretch, however. Astringents are usually tannins, which are compounds found in plants or fruits and are found in many cosmetic products, none of which are found in mildly acidic water. And there's little to no evidence in the literature that mildly acidic water has this effect, nor any other benefits for the skin. But we still have that pH thing going for us, right? True, but something else that is unknown to many proponents of this water is that many times it contains chlorine. So even though most water ionizer filters will remove chlorine from the water, it will not filter out the chloride ions. These chloride ions will oxidize at the anode to produce chlorine. Some ionizer water filters contain calcium sulfite, which will reduce the generation of chlorine at the anode. But the calcium sulfite in the filter will not last the entire life of the filter. So eventually you will start producing chlorine in the acidic water again. And given that chlorine is a mild irritant to the skin, I wouldn't call this mildly acidic water something that's going to give you beauty. I would definitely test for chlorine regularly before you use this water on your skin. This can easily be done with chlorine test strips or drops. The last special water we're going to be covering is strong acidic water. Strong acidic water is often referred to as electrolyzed oxidizing water, or 2.5 pH water. This water is produced at the anode or positive electrode on the highest applied voltage setting. In most cases, salt is added during the electrolysis process. The water generally has a pH of 1 to 3. The chemical agents that can be found in this water are primarily chlorine gas, hypochlorous acid, and oxygen. The claim is that this water can disinfect or kill bacteria, and some say it's better than any disinfectant that you can get at the store. Now, I have some good news and some bad news about this water. Let's start with the good news. The good news is that hypochlorous acid really is a remarkable killing agent. Next to H2, it is one of my favorite molecules and my family uses it regularly. So let's talk a little bit about what it is. Hypochlorous acid, or HOCl, is the most potent environmental disinfectant of the chlorine species. It has a high antibacterial activity against a broad spectrum of microorganisms. It is 80 to 200 times more effective at killing microbes and pathogens than household bleach. It has been demonstrated that bleach requires 6 times the contact time for killing than hypochlorous acid at equal concentrations. Since hypochlorous acid is neutral in its charge, it is remarkable at penetrating bacterial biofilm and pathogen lipid bilayers. Hypochlorous acid kills bacteria by penetrating or diffusing into pathogens and oxidizing sulfur groups, amino acids, etc., which are associated with the bacteria, virus, or fungi's ability to make energy. Hypochlorous acid has been demonstrated to be an effective antimicrobial and continues to be studied due to its active agent effects against all pathogenic organisms. What is also cool about hypochlorous acid is that it's naturally produced by human immune cells, or neutrophils, to ward off infections. The surprising part about hypochlorous acid is that it's highly effective at killing, but it's more biofriendly to human tissue than bleach, which is irritating to eyes, skin, and lungs, and can have carcinogenic effects if overly exposed. This makes hypochlorous acid suitable for external human use and possible medical applications. Check out this quote. Conclusion: on the basis of the antimicrobial activity and the lack of animal toxicity, it is predicted that stabilized hypochlorous acid has potential pharmaceutical applications in the control of soft tissue infection. And this one says hypochlorous acid is a potent antimicrobial agent and has advantages such as non-toxicity in biological tissues and is environmentally friendly. Hypochlorous acid is naturally produced via water electrolysis, which makes it inexpensive to manufacture and readily available. It is used in a number of applications, such as medical sanitation, wound care/healing, skin care, disinfecting meats or produce, etc. It is arguably one of, if not the best disinfectant we have currently discovered. Now, here is the bad news. Much like hydrogen gas, just having the presence of hypochlorous acid is not enough to ensure its effectiveness. Hypochlorous acid needs to be at an appropriate concentration level and then an appropriate contact time for that level to ensure a kill factor. And truth be told, ionizers are not the most effective at producing hypochlorous acid at optimal levels for killing. One reason for this is that hypochlorous acid does not prefer a low pH, but rather a pH of 4 to 6. As noted by this graph, hypochlorous acid exists in water predominantly at a pH of 4 to 6. Chlorine gas exists predominantly at a 1 to 3 pH range. And hypochlorite, also known as bleach, predominantly exists at a 7 to 11 pH range. So as you can see, water ionizers produce this disinfectant water at a very low pH. The low pH results in high levels of chlorine gas and relatively low levels of hypochlorous acid. This gives the water a strong chlorine smell. This is also a popular demonstration to smell the strong acidic water as proof of its effectiveness. But ideally, water that has high hypochlorous acid levels won't have much of a smell at all. So this is one way to indicate what is predominant in your strong acidic water, what it smells like. Also, not all strong acidic water will have hypochlorous acid. The source water must contain chloride ions for electrolysis to be able to produce hypochlorous acid. As a side note, even if your ionizer system has a granular activated carbon filter and the tap water is chlorinated, chloride will still be present in the water after the filtration. This is because GAC filters convert chlorine to chloride. Anyway, some ionizers will have a saline enhancer to guarantee the presence of chloride. But even then, the concentration of hypochlorous acid in the water will determine the contact time, or how long it'll take to be able to kill pathogens. Ionizers can produce hypochlorous acid levels so low that it may take longer than 30 minutes of contact time to even be effective. Really, you just don't know unless you test it. There are easy to use hypochlorous acid test strips that I use that I will link in the description. Before you ask, no, I do not use a water ionizer to produce my hypochlorous acid. I use a specialized device to produce mine. But the main point is that it isn't as easy as saying this water from a machine will for sure kill 99% of all bacteria. There's just more to it than that. And that is the case with all of these waters we have talked about, and even the drinking water we have talked about in the last few videos. Even if there is a tiny bit of truth in what has been claimed, it is definitely not as simple as it sounds. And the details matter so that you can know that you're getting the benefit from the water that you're using. Believe it or not, these special waters are big selling points when it comes to water ionizers. Our goal is just to educate so you can be aware of what you're actually getting when it comes to these waters. In full disclosure, I have been the one before making all the claims when it comes to these waters. So I know firsthand what it's like to learn that what you have been promoting is not exactly true, which is exactly where I'll be heading in the next video. I talk a lot about the science of hydrogen and related topics, but I've never actually told my story and how I got here. Next month is story time at H2 Minutes. I'm excited to tell you guys how and why I make these videos. Big thanks to our patrons on Patreon, especially these guys on the screen. Please consider becoming a patron if you like what we do and want to see more. Also, if you just like the content and you want to support us with a one-time donation, you can do so in the link in the description. We literally cannot do this alone. Don't forget to like and share this video. And that was your very special dose of H2 within minutes.